Good morning, students. This video is a short video explaining the stoichiometry lab that we were supposed to do Wednesday, March 18th. So today's Wednesday, March 18th. This is something that you can do anytime, I would say this week when you have time. So what I'm putting in the announcement here is I would like you to download, we're not going to do anything in the lab book pertaining to this lab. In fact, I had written like a substitute lab for this. So I want you to download, it's a 2-page document, and this is the only thing that you need to complete for this lab, is this 2-page document. I'm going to explain how to do it. What I'd like you to do is complete the document sometime this next week and take a photo of it with your phone. It doesn't have to be a good quality photo. Let's test this out to see if this works. Just take a photo of both pages with your phone. See if you can email it to me. That's kind of how I'd like to collect this, and we'll see how that works in terms of turning assignments in. I'll be flexible with the due date, but I think a good thing would be to try to get it done by next Wednesday. Like I said, don't worry about the quality of the photo. I'll be able to see your writing. Just take it. One quick thing also, if you do not have a printer at home, ideally you can print this out if you have a printer, and that would be probably the easiest way to do this. However, a lot of people might not have a printer at home, and I know libraries are closed and FCC is closed too. So if you don't have a printer, just write down the answers that you would write down on a piece of notebook paper. I don't really care that much. Just get your answers on a piece of notebook paper and take a picture of that notebook paper. Try to make it a little bit neat, but you don't even have to like recopy everything. So you can look at it on your phone or whatever technology you're using to see the document. And if you want to just write stuff down on notebook paper, fine, no, not a big deal. And any issues with technology, please email me and let me know where you're at, and I'll work with you. Okay, so I'm assuming you have this document, or at least you've seen this document. So essentially what you're doing in this lab, it talks about the purpose of this lab, is you're going to be, it's a precipitation lab. So in the last time we did precipitation reactions, you all had those little test tubes, and you added 20 drops of this reactant, 20 drops of this reactant, and you looked at the little test tubes and you saw if it turned turbid or not, which meant that there was a precipitate. And you recorded whether it precipitated or didn't precipitate. This is essentially the same type of reaction. We're still doing a precipitation reaction. The difference with this lab is that you are designing the whole lab in order to obtain or to make 2 grams of that precipitate. So you're kind of combining precipitation reactions with stoichiometry. So the purpose is to make 2 grams of a precipitate. It says of a compound, but it's really of a precipitate. So the lab requires you to choose 2 reactants that will make a precipitate. So for that, you're going to be designing, okay, which 2 reactants do I think will make a precipitate according to solubility rules? And then you have to do some calculations to find out how much of each reactant do you need to add together so that you get 2 grams of precipitate. That's a stoichiometry type of calculation. And then the third thing is to follow the procedure. Obviously, you're not doing the procedure, but you can at least think through the procedure. And then collect the precipitate. Once again, you're not doing that, but we can at least, you'll see at the end of this lab, I give you a kind of a fake actual yield, and you can calculate a % yield. So the first thing that I need to teach in order to do this lab is if you're looking at part 1 of this piece of paper, let me hold it up here, see if you can see this here. Part 1, it says, formulas and molar masses of the compounds. So essentially in this lab, you are going to be given 6 different choices. The first one being calcium chloride dihydrate, and then 5 more over here. And what you'll notice is that 4 of these 6 compounds have like a third name. So all of these are ionic compounds, but 4 of them have a third name beyond the name of the cation and anion. And they say dihydrate, heptahydrate, monohydrate, heptahydrate. So how to explain what that's all about is just a short little thing to put in your notebook. This will not take long. What you need to learn for this lab are what are hydrated ionic compounds. What does it mean to be a hydrated ionic compound? This is something that is taught in this lab. So the good news is that it's not a very difficult concept. Hydrated ionic compounds are just regular ionic compounds Once again, ionic compounds will just have cations and anions joined together in a lattice structure through ionic bonds, and you'll have as many of each type as you need to get something neutral. Just regular ionic compounds that have water molecules trapped within their lattice structure. So they are hydrated. Hydrated obviously has to do with hydration. If you're dehydrated, you don't have enough water. That's what this is all about. So water molecules trapped within their lattice structure. So what I will do is use the very first one. I'll do the first one with you, and then you'll have no problem doing the other 5. One thing that we're going to have to learn how to do is how to write the formulas for hydrated ionic compounds. So the first one is called calcium chloride dihydrate. Okay, so this is one of the ones that's hydrated because it's got this third last name. Okay, so to write the formula, all you do is look at the first 2 words. Okay, that's his regular ionic compound formula, calcium chloride, and just as usual, write what the formula would be for calcium chloride. So calcium, obviously, we know is the metal, chlorine is the nonmetal. Calcium, therefore, is the cation, so we know calcium forms a 2+ cation because of his group. Chlorine forms a 1- anion because of the halogen group is always 1-. So his formula, everybody should know by now, is CaCl2. Okay, so if we had to picture what this looks like in the lattice structure, what that means is that there is a single calcium cation for every 2 chloride anions. And that's what it means. That's why, we needed 2 chlorides to balance out the 1 calcium. We get that. So to have a neutral charge. What it means when it says dihydrate is that this is just your traditional prefixes, di meaning 2. What this means is that for every single calcium chloride formula unit, so the 1 calcium and the 2 chlorines, you will have 2 waters stuck inside. And so it looks kind of like this. 1 water molecule would be here, just anywhere, stuck inside. So that is what calcium chloride dihydrate looks like. So that's one of these. If I had another, if I kept drawing the lattice structure out like the salt crystal, and I drew another calcium 2+ and 2 more chloride anions, I would have to add 2 more waters. And that's kind of what that means. It's just telling you how many waters are stuck inside. Now, in terms of the formula, the dihydrate shows up here. Whenever you have a hydrated compound, you have a little dot right there. It's not like a period, it's floating. It's in the middle of the zone there. And you do dot, and then you do however many waters there are. And that is what you would write for the molecular formula for calcium chloride dihydrate. If it's not hydrated, like for instance, the third one, potassium carbonate, you just leave this part out. If it's not hydrated, that just means there's no water molecule stuck inside. So I'll leave you to write the formulas for the next 5. Just keep in mind, remember, zinc is always a 2+ ion for number 2. Hepta, I'll let you remember or at least look up what that prefix stands for. Now, the molar mass. The molar mass of these compounds, of the hydrated ionic compounds, will have to contain the mass of the waters. Because keep in mind, the waters are heavy too. The waters have a mass too. So when you're calculating the molar mass, for instance, let me do the first one with you here, of calcium chloride dihydrate, you're going to have to add up however much calcium weighs with however much 2 chlorine atoms weighs with however much 2 water molecules weighs. I usually just do a water molecule is 18.016 grams per mole. And so, I always have that one memorized, and then I just times it by however many they have. So 2 of them. So if you go ahead and calculate that, you should get, for the molar mass, 147.012 grams per mole. So go ahead at some point, get the formulas for all 6 reactants and get all of their molar masses. That's one of the things that I can grade for this lab. All right, so now moving on to the next part, I'm going to kind of just explain how to do this whole lab here so it's not too hard for you. The next part is writing the complete molecular, which is just the regular balanced equation, 2 reactants, arrow, 2 products, and it's just a precipitation reaction. Your assignment is to choose 2 of those reactants that will form a precipitate. So I'm going to do an example, but you're not going to be allowed to pick the same 2 that I choose, okay? So otherwise you'll just end up writing what's on the board. So you're going to have to pick 2, a different combination. You can choose one of mine, but you can't pick both, okay? So there's many choices that can work that will be correct. So let me just pick 2. So let me pick, how about I will pick calcium acetate monohydrate. So calcium acetate monohydrate. Calcium acetate would be, that would be calcium acetate. Monohydrate would be just a single H2O trapped inside. And I think I have a little note underneath that says the 2 reactants, when you read the procedure, they're going to be dissolved in water. That's how you would have masked it out, gotten that certain amount of this reactant and dissolved it in water before you added them together. So just go ahead and assume that they're going to be aqueous. Let me pick a reactant that will make a precipitate when combined with this. Now, it's a partner swapping thing. We've already talked about this. And if you look at your solubility rules, anything that contains acetate will always be soluble. So whatever guy gets partnered with acetate is never going to be my precipitate. It's never going to end up giving me a precipitate because it's always going to be soluble. So I've got to pick something that has an anion that when combined with calcium will precipitate out. So how about something like, okay, I'm seeing that if it contains carbonate, I'm looking at my solubility table here. If it contains carbonate, CO3 2 minus, it's going to be generally insoluble. And calcium's not an exception to that rule. So that means calcium carbonate will be a precipitate. So I've got to pick somebody that has carbonate as an anion. So how about, I'll pick, it doesn't really matter. How about I pick sodium carbonate? So Na2CO3, he's also going to be aqueous. And now all I need to do is figure out what the products would be. So this is the partner swapping thing. So I'll just remind you that it kind of goes like this. So what would the two products be here? Calcium and carbonate would be one of them. And you would just have a 1-to-1 because one of them, that's 2 plus, that's 2 minus. So he would be solid. As according to my solubility rules, he's the one who's precipitating out. And the other product would be whatever ionic compound you get with sodium and acetate. These are both 1 plus and 1 minus ions, so it's just going to be a 1-to-1 ratio. This will definitely be aqueous. So remember, at this point, we're not balancing the equations. I'm just trying to figure out what the compound would be that gets me neutral between sodium and acetate. And that would be it right there. Now, how do we deal with the water? Because obviously you've got this thing here and you've got to have a balanced chemical equation. I also have it in the notes here. If either or both of your reactants are hydrated ionic compounds, there is going to be a third product. And I think you guys will all end up finding that you're all going to have that situation. There is going to be a third product, and that will be H2O liquid. So definitely make sure you write your third product in there, because once you dissolve this hydrated ionic compound, I erased it here, but all of those, remember when you dissolve an ionic compound, the ions dissociate. All the cations will separate from the anions, and just like common sense, those water molecules will be freed. They'll be allowed to leave as well. And so that will be kind of like a third product of that reaction. All right, and then all we have to do is balance the equation. These should be pretty easy to balance. You can see there's 2 sodiums and 2 acetates, so easily I can see you're going to have a 2 right there. And then how many waters? You will have to check how many waters. If you had to add a coefficient here, or if you didn't have mono here, just however many waters you get, just make sure the water's balanced. This is a 1, and there was only 1 copy of it, so it stays a 1, and therefore this is still a 1. Okay, so I've got my balanced chemical equation. Now, part number 3 says you have to calculate what is the mass of this reactant. Let me get rid of these little bracket things. what is the mass of this reactant that you need, the first one, and what mass of the second reactant do you need? So let me underline here. The goal is to calculate the amount of grams of this reactant and the amount of grams of this reactant that you need in order to obtain exactly 2.00 grams of this product. That's the goal. So this is a stoichiometry question because we're given information about the product. We want 2 grams, but we don't know how many grams of the reactants that we need. I'm not necessarily going to do this whole thing for you just for the sake of time, but let me just get you started. You always start with the number in the question, and the number in the question here is that you are trying to get 2.00 grams of that precipitate. In my case, it's CaCO3. By the way, depending on, you all just, let me just reiterate it one more time. When you do this, you can still use this one or this one. You just can't use the same combo. You're going to have to pick a different partner, okay? So just any 2 that will make a precipitate. Just don't use my thing too. Okay, so you're going to start with this number, 2 grams of CaCO3, and really you're going to be doing two calculations. Start with this. Go ahead and convert this to moles. I'm not going to do the whole thing, but you'll use the molar mass, whatever that is. And then, so whatever that molar mass is, and then stoichiometry. So it's coefficients. So in this case, for every 1 mole of CaCO3, if I was to calculate this one first, it's for every, you would need 1 mole of Ca, the calcium acetate, and then you would just use his molar mass, calcium acetate's molar mass, to figure out how many grams of calcium acetate you need. So it's just a stoichiometry question, and you would get whatever answer. That's your first answer. That's how many grams of this reactant you need. And then as a second equation, you would start the very same way. You still need calcium carbonate as the product. Okay, you're still trying to make 2 grams of it. But this time, and you, once again, convert it to moles because you've got to get everybody in moles if you're going to do stoichiometry. This time, the question would all be about this second reactant. And in mine, it's still a 1-to-1 ratio. You might find that yours is not a 1-to-1 ratio, depending on which ones you choose and how it ends up balancing. And then you would use the sodium carbonate's molar mass to finish this stoichiometry problem. And you would get the grams of the second reactant. So hopefully you kind of see what we're doing here. So that's really, the key is knowing where to start. You're trying to get 2 grams of your precipitate, and then you just stoich out, pivot to him first, and then pivot to the second reactant second. And then just circle your answers. It's going to be somewhere in the, if you'll know you're right if they're usually somewhere between like 1 and 6 grams. So it's not going to be like some, huge number or some tiny number. Go ahead and just peek at the procedure. Let me just explain what you would have done. At this point, you would have figured out your 2 masses. Like say this was like, 3.5 grams and 2.5 grams or something. You would have gone to the bench or to the balance. You would have weighed out your 2 reactants, dissolved them in water, gotten them in 2 separate beakers, nice and dissolved, because they are both soluble, which you'll find with your solubility rules. Then you would have combined them together, and you would pretty immediately have seen a precipitate, a nice white cloudiness. And you would have allowed it to precipitate for several minutes. And then the whole goal would just be to collect it on a filter. And I was going to show you how to filter it, but it's, it's fine. So you'd filter it, you'd collect it on a filter, and then we were going to air dry it for 2 weeks, and then we were going to weigh it out and see if it weighed 2 grams. Usually it does not weigh 2 grams because you lose product on the filter, you lose it on the beaker. It's just a, a typical type of reaction. It's never 100% efficient. And so that moves us to part number 4, and you're almost done here. The percent yield calculation. See, hypothetically, if you had, at the end of this reaction, obtained 1.57 grams, so let's just pretend for everybody's sake, everybody got 1.57 grams, what would your percent yield be? And that is the final calculation. I want you to calculate what your percent yield would be had you actually obtained 1.57 grams of your precipitate. And so then you would just circle or calculate that, show me your calculation and circle it. So just circle your answers, fill it out. I don't expect it would take too long. I will also put another solubility table up on Blackboard in case you're missing yours. And if there's any questions, feel free to email me. And if it's a question that I think everybody is going to have, I'll put up another Blackboard announcement just to clarify. But hopefully that was good enough explanation of this lab to let you do it. So we'll just keep on trucking along. Hopefully we'll be seeing each other again in a few weeks. But we'll just keep trying to learn as best as we can while we are not seeing each other. So I hope you all are doing well and that you end up having a good day today. And be in touch. Like I said, I'm on email, so just email me if you have anything that you need to share or questions or whatever is going on. Okay, take care. Bye.